It's not on mute.
Wait. Yeah, there we go. Okay, now we're up now.
Was it muted the whole time?
Yeah, it was.
Oh.
Okay, everyone. Welcome to the COMP1511 Assignment 2 live stream. My name's Rory Gullidge. I'm here with Ben and Sasha. We'll be introducing Assignment 2. You guys probably haven't seen me around at all with 1511. I've just been working on a couple of things in the back, but I'm here for Assignment 2 to go through the spec and answer any questions you guys have. So, right away, Assignment 2, go to the course webpage, scroll down, and you should see it right here. There's a fantastic artwork by Ben
Thank
that he
you.
made in Paint. I think he's going to drop his honours and become an art student. So, click on that, you'll get taken to the Assignment 2 page. Assignment 2 is basically all about linked lists and manipulating them. So I know that we only just introduced linked lists yesterday, I think? Wednesday, yes. So even if you're just joining the live stream live, don't stress if you don't understand everything that's going on. Hopefully over the next couple of weeks, we'll be teaching more about linked lists, you'll do all the lab exercises, and it should be okay. So I might just ignore the assignment structure here for now because there's no point explaining it, I think, without actually going through the code itself. It's going to be a bit hard to understand. But essentially, assignment 2 is about making a to-do list. So this is a pretty common programming thing that you might do when you first start out. But it's just to really teach the ideas of linked lists and actually get you to kind of create a program that you could use in the real world, essentially. Having a to-do list is a pretty common thing for people. I personally don't have one, but I probably should. I know Sasha has one. I don't know about Ben.
I kind of have one that has nothing on it at the moment.
And then Ben has been forced into one.
Wonderful. So this assignment kind of structured the same as assignment 1 in terms of everything on the website. I'll come back to all this stuff later once we actually go through everything that we're doing. But the main thing to look at here essentially is that you're going to have some to-do list up here, and it is essentially going to be your struct that encapsulates the entire program, and it's going to contain a couple of linked lists, which we'll get into. So we'll scroll through all of that. Basically, the structure for assignment 2 is in stage 1.1, we'll get you just to set up the to-do list itself, so just using malloc and setting all the fields that we need to. And then everything from stage 1.2 onwards is just going to be commands, essentially. So just like assignment 1, I believe. Yeah. So let's get into it then. Don't worry about that note for now. So first thing you want to do with this assignment, actually set it up. So make sure you get on your favorite terminal in VLab, make a directory, assignment 2, go into that directory, and then from here, just copy this command. And then I should be able to paste it in. Awesome. And so this will actually give you the starter code for the assignment. If you're working locally, sometimes you have bad internet, it's just easier to do it locally. Feel free to just download the starter code here. It should be the exact same thing. So just download that and you can work at home as well. So cool. Press enter. It should create a file if you press ls now, this cs2.c. And the first thing you do before you do anything else, just run the auto test. So 1511 auto test cs to do, just to sanity check that you copied the right file. Sometimes you might accidentally have a typo in here. Just double check it, press enter. If everything is failing spectacularly, that means everything is working. If it says file not found, that's when there's probably an issue. So make sure that you use that command again, make sure it works. Cool. So let's just get rid of all of that for now and move on. So make sure you read through stage 1 as well. That's what we're going to be going over mostly today as the majority of it, because this is about getting you started with the assignment, as well as just going through all the stages, everything that we're doing. All right, and I'm going to mention this a couple of times throughout the lecture. Draw diagrams. Whenever you start a new command, a new task, draw diagrams for what's going on, how everything's going to work. Because with linked lists, it's very hard to visualize what's going on the first time you really look at them. So drawing out diagrams, doing all that kind of stuff, really helpful. Okay, so the starter code. I'm going to open it up. and brace yourselves because there is a lot of starter code, but we're going to go through it and it's not going to be as scary as it might look. So if you open up this new copied file, you'll notice there's about 450 lines of starter code. A lot of it is just helper functions to make your life easier, and pretty much all of these helper functions, you don't need to understand how they work. Don't stress about all of it. The main things you need to care about is at the top, there's these hash defines, all here. There's this enum priority, which we'll get into as well. And then there's all these structs here. And so these structs and the priority are essentially what your entire program is going to be. It's just going to be made up of all these things, and you're going to be writing code to actually manipulate all these things. So once again, don't stress about all the stuff that's going on anyways. We'll get to what everything means here, but we've got an enum priority. So this is essentially going to be when you create tasks and you add them to the to-do list, you can add a different priority for them. We made it an enum because often there's only a couple of options for a priority. So that's just the reason we did that. We've got a struct task, which contains a name, a category, and the priority itself, as well as a pointer to another task. So the idea here is that we're going to have a linked list of tasks, and each task is going to have its own information, as well as a pointer to the next one. Cool. Completed tasks we'll get to later, but this is essentially going to build on the idea of a task, and we're going to have another linked list of completed tasks as well. Then there's the big struct that kind of encapsulates everything, which is the to-do list struct. And this will essentially just contain a linked list of tasks and a linked list of completed tasks. And this is just saying that like this is a pointer to the first task in the linked list. This is the pointer to the first completed task in the linked list. So yeah, bit of overload there, but hopefully that makes sense. Moving on, here's all the function prototypes I was talking about. Once again, don't worry about them from now. We'll prompt you in the assignment when you need to use them. There's a lot of stuff here, but don't stress about it, basically. The stuff you need to care about is your prototypes here. We provided one because we decided to be very nice this term. And the main function down here. So we have a main function, very small, very nice. This main function should not get any bigger, really, maybe 1 or 2 more lines of code. But essentially the idea is that in stage 1, what you'll be doing, if we scroll down here, is you'll be setting up the to-do list. So we've got this struct to-do list to do, and we essentially want you to malloc a new to-do list here. So we won't show you how it's done because it's stage 1.1, but you can imagine that instead of having null here, which I'm going to have for now, you can say malloc to-do list or whatever you need to put in there. I won't say the exact syntax. And then make sure every time you create a new struct, make sure you fill in all the fields as well. Hopefully everyone's done the checkerboard exercise, which I think is when that can be the most annoying, when you don't fill in everything. So make sure you fill in all the fields of the to-do list after you malloc it as well. And then we get to the command loop. So this is essentially where everything's going to happen, this function here. And it's right below, a nice little function here. And hopefully this should look a bit familiar to you guys. So in assignment 1, we got you to create a whole command loop to go through and scan commands, do things based off that. In assignment 2, it's the exact same, except we actually provide the command loop this time, just to be a bit nice about it. But essentially, if you read through this, it's just like print out, enter command, loop through, take in a command, do something with that command, and then repeat the entire thing all over again. So if you actually compile this as well, hopefully it should be fine. Yes, awesome. And then you run it, straight away you'll get this enter command. So you can say like, oh, A, and then other things. I'll just put A in for now. And then you'll see it starts looping. So you can put other letters in, just like with assignment 1. And then to stop a loop, Control D. So that's essentially the whole structure there that we've given you, just to make your life a little bit easier. Now in stage 1.2, this is where we'll actually get you to manipulate linked lists for the first time in an assignment at least. So this stage, it takes in a command, A, and then it has a whole bunch of stuff after it. So it's got like A, the task, the category, and the priority. And this is basically all the information that you're going to need for a add command, essentially. So when you go and add a task, you need to know what the task name is, what the category is, and what the priority is. And we're actually going to use that to create, essentially, if we scroll back up, one of these things, a struct task. Cool. So make sure to read through all of stage 1.2. There's a lot of useful information in there, but essentially just goes over like why we need this, what's the point, and all the specifications of what you should be doing in this task or this exercise. Okay, so what I recommend for stage 1.2 is first thing you do, create a helper function for it. So I'm going to do that as well, so you guys can just copy it when you actually start the assignment. But just create void add task, takes in a to-do list, and this is going to be the to-do list that you actually created at the start. And then inside of here, you're going to do all the code related to add task. So maybe add a header comment up here. So just say something like, takes in a struct to-do list and scans in a new task, adding it, put that on the next line, adding it to the to-do list. Just like so. And now in here, there's a bit of an annoying thing that we're gonna have to get you guys to do, but we should hopefully have given you enough information to do it. Essentially, when we take in a command like A, it's followed by a bunch of strings that we need to like split up and get into different variables. We don't really want you guys to do that because it's not the point of the assignment, but we still need to do it so we can actually do the assignment, right? So we provided you with some starter code here that you should add to this add task function. And so if we copy that over and paste it, and then we can just, I don't know, tab it all forwards like that. So this is a bunch of starter code we provided. I will go through it line by line because it is a bit confusing. But essentially, what we need to do is we've got all this text we need to take in and then split up. And so this is what this code actually does. So first off, we need to take in all this stuff after the A and then put it into an array of characters, right? Because we need to actually like fill it up and then we're going to split it up afterwards. So we're going to get our favorite friend here, fgets. Hopefully everyone is masters of fgets by now. Just joking. I think fgets can be a bit confusing when you first start out. But if you are a master of it, good job, because that's amazing. But essentially, just a quick run through of how fgets works. It takes in a variable at the start. That's essentially an array of characters. It's the thing you want to scan into when you're scanning an entire line of input. So the array of characters to scan into. And then the second thing you want to do is take in how many characters you want to scan into the maximum amount. So maximum amount of characters to scan in. And then the third thing we always just say is std_in. And this is basically just saying that I always want to take input from the terminal. In this course, we only take input from the terminal, so just always put std_in there. So take this input from the terminal, essentially. So that was just a quick refresher of fgets. Feel free to just take a picture of that or come back to the live stream to have a look at it if you need to. But this will essentially just get all our like stuff that we put into the terminal here, which is awesome. Then what we need to do is kind of split all this stuff up into different variables. So how we do this is we create these three variables here because we know we want to have a task name, a category, and a priority. So we're essentially creating these variables here, right? Task name, category, priority. But then it's a bit weird because we don't actually like set them to anything. We don't give them any values. And so we provided this nice function here, pass add task. It's a helper function. You can find it in the code if you want. I won't show it because it's a bit confusing and you don't need to understand how it works. Just know it exists in the code and we'll always prompt you what to enter. And I changed this. This is the wrong function here, but it should be updated on the course website. Hopefully, if I refresh it maybe. It did not like that.
Oh dear.
Okay, no, that's fine, that's fine. It should be updated on the course website. I won't worry about it for now. Okay, so pass add task, and this should also be line here, which I thought was updated as well. I'll double check this at the end of the live stream, but this should be pass add task line. So if it's not on the website, I'll put it up, but it should be there anyways. Essentially, this function here, it will take in this buffer, we called it, buffer is just a fancy word for an array of characters that we like usually just scan stuff into. And that's the thing we created up here, right? The buffer, we scan in all the stuff we need. So for example, if we said A, finish task 2, assignments high, all this text gets scanned into the buffer. And then we also provide task name to the function, task category, and task priority here. Task priority, you need to take in the address of it, because when we actually do this this pass add task line, what it's going to do is it's going to fill up all these variables we have. We know that arrays are kind of special, so when you pass them into a function, you can actually modify them, and that's because of like pointers under the hood as well, but we won't go into that. And then the priority itself needs to be passed in as an address because we actually want to change the enum itself. And so the really nice thing about this stuff here is that this would do it all for you. And so I could actually go ahead now and print out task name %s, and then actually provide the task name like that. And so we'll just put all this stuff here, task category, task category. One issue here, it's kind of hard to print out enums because they're not really like meant to be values. What we can do instead though is if we wanted, we could just say, I don't know, if priority is equal to high, because if we go back up to the enum priority up here, it could be any of these values, right? So we're going to say if it's high, maybe we'll print out high or something like that. Where were we at? Cool. So if it's equal to high, we'll just print out. Oops. Task priority high. And then we can also say like else if priority is medium, print out medium, else if it's low, print out low. But we won't do that for now. We're just going to say this is what it looks like. If they input high, we'll print out high. Otherwise, we just won't print it out. This is just to show you guys how it's like going from this function, putting it into all the variables, and then you can actually use them how you want to. So if we DCC again, and we name our variables correctly, like so, save it, cool. Then what we'll see is that when we now do this add command, we're gonna say A, and then we'll say, I don't know, watch live stream. And then we'll say it's for 1511, that's the category. So watch live stream is the name, 1511 is the category. And then the priority we'll say is high as well. So if I press enter now, we get a bunch of stuff here. And the reason this happened is because I forgot to actually call the function. So, good note here, copy the function, make sure you actually add the prototype for it. So all the way up the top to our prototypes here, paste it up. And then let's go back to our command loop, because in our command loop, we actually need to call the function. So let's say add task, and then we pass in the to-do list like that. Now we're actually calling the function, so now it should not just give us a bunch of enter commands and be very sad about it. So let's try that again. I'm going to say add watch live stream 1511 and hi, and hopefully we will get this. So now we see that after we've done all this stuff here, it's a lot of boilerplate code, and we do apologize for that. But it's the easiest way for us to get you guys to just scan in and type lines at the moment. Once you've done that, what you'll notice is that task name is watch live stream. So we split it up into one variable. Then the category itself, 1511, so now it's one variable as well. And then the priority is high. It's not the string high, it's the enum priority high. So we can also add like the else if we wanted as well. But that's the idea there. And then you can kind of imagine, if you're at this point in the code, you could create a new struct task, right? So like struct task, you might need to make this some kind of malloc because we're using linked lists, but I won't go into that at the moment. And then inside of that task, you could actually add these strings and this priority. So if you go back up to the struct here, you'll see that a task is made up of kind of what we just went over, right? It's made up of an array of characters, that's a task name, an array of characters, that's a category, and an enum priority, which is, it's a priority that's an enum priority. And so you kind of just fill up this task after you've passed everything. So this is probably one of the harder parts to get over when you're starting the assignment. But once you do that, you should be golden to keep going. You'll need to do this a couple of times for a couple of the commands when they require more than just an A. So like, for example, in stage 1.3, we have to print out tasks. It's just the command P, so you don't need to like take in, like pass this entire line, it's just one command. However, if you went down to stage 1.4, it's I task category. So as a result, you will need to do the same kind of thing with a different function. So just keep in mind, just read through the spec, and then you can follow it. It'll help you out with all this kind of stuff. We're meant to be testing you on linked lists, not on your ability to pass every single line that we give you. So don't worry about that. So back to stage 1.2, adding tasks to the to-do list. So you might be looking at this and then it kind of doesn't tell you much about the actual exercise apart from adding a task to a to-do list. So if you are ever confused about like different edge cases you might run into, it's always useful to look at the assumptions, restrictions, and clarifications. So for example, new tasks should be added to the end of the to-do list. So not the start, not the middle, you should always be adding to the end. Next one, the same task will never be added to the to-do list. This means that you can never have a task with the same name and category. They'll never be added because it'll make life much harder otherwise in later stages. So we've just said that as a blanket thing. However, you can have the two tasks that have the same name but different categories, and vice versa. You can have the same category but different names. So just keep that in mind. All assumptions will be in here. If you find a case that you're not really sure of and it's not here, ask on the course forum. We are very happy to change the spec and like, or not the spec itself, but we're happy to add assumptions. That's okay with us. Cool. You'll never be given other priorities than these strings here. So don't stress about that either if you're thinking about it. Yeah, awesome. So at the end of every single stage, you will have this header here. If you don't have that header, that probably means there's not really any assumptions we could have thought of, or they're all mentioned in the spec. So just double check that as well. Okay, and then one important thing for stage 1.2 is that you will not pass any of the auto tests. You won't even really be able to test your program until you finish 1.3. And this is a bit annoying, but it's not really something that we can fix completely with this assignment. So the point is that like you can add to a to-do list as many times as you want, but how do we check that we actually added successfully, right? We can't. There's not really a nice way to do it, except if we did what we do in 1.3, where we can print out all the tasks. So this command here, P, will literally just print out your entire task list. And once you do that, you'll actually be able to run the auto test for 1.2 and 1.3, which will be nice. And I will actually show you guys now how 1.2 and 1.3 can be used together. So it should be somewhere in the spec, a command to use the reference solutions. Ah, perfect. Yes, so this command here, 1511 CF to do, this is a fully working implementation of the assignment. So if you're ever confused about something or you don't know how it should possibly work, it's always good to just go through the reference and then double check what it's doing, because that'll essentially be what your program should be doing as well. Unless there's a bug. Hopefully there are no bugs in it. No bugs, no bugs. So let's run this. Let's run 1511 CS to do. We'll get the same kind of prompt that we had before to enter commands, and I will add a bunch of commands. So we'll add watch live stream for 1511, priority high. We're going to say read assignment 2, 1511. We'll say the priority is low for the moment because it just came out, but go through it soon anyways. And then maybe we'll say something just a bit more random. Buy milk. Personal. And we'll say it's a medium priority. Like so. Now, if I press P, we should see an entire, essentially, to-do list printed out. So I press P and we see this whole stuff get shown on the terminal. And you'll notice that the order that I added different tasks is the order they appear in here. And that's essentially done because we're adding to the end of a linked list every single time. So if we go to print out the linked list, we'll print out the first thing, then the second thing, then the third thing, and so on. Awesome. And so this is essentially how adding and printing will work. And once you've done those two things, I think they're probably some of the hardest stuff when you're first getting to the assignment. So once you're done with these two, I reckon the rest of the assignment will be a bit easier for the first and second stage at least. So yeah. And another thing, I know with assignment 2s, they can be really hard to get into because there's usually a lot of starter code, a lot of stuff you need to understand. I find it easiest to actually just start coding, start actually trying to do stage 1.1 and 1.2. Oh yes, sorry. Before you start coding, draw a diagram of what's going on. That's definitely a good point. So yeah, it's great to have all these linked lists and adding them and printing them, but it's always good to have a mental model of what's actually going on in the code. You can write all these functions to do all these things, but you might get to a point in the assignment and you're like, I don't know what's going on, and I don't know what I'm doing, which definitely happens. And I think this could trip up a couple of people when it comes to stage 2, because it's really important to understand what's going on in the linked lists to properly do all those exercises. So draw a diagram of what's going on, and then start coding it up. And also, we provided a couple of diagrams for you guys. So stage 1, here's a diagram here. It essentially just shows there's a to-do list, which is like the thing encapsulating all your data. And then there's the linked list of tasks here. So this is essentially the mental model that you should have at the end of stage 1, or at the start, and then what it's going to look like at the end of stage 1. Then stage 2, you also have a more complicated diagram, but we'll get to that in a sec. Okay, so that's stage 1.1, 1.2. Are there any questions about it? No, awesome. So 1.4 now. Essentially the rest of stage 1 is just testing your linked list knowledge and doing various things with them. So usually like looping through and determining different properties about your linked list. So for example, this one here, update priority, what it does is it's the command I, it takes in a task and a category, and then you need to update the priority of it to be one more than it used to be. So probably best to go through examples here, to be honest. In here, we say add finish assignment 2, assignments medium, so that's a new task. We can print it out. We see that's what it looks like. And then if we use the I command here for that task and that category, then we'll see that the priority has actually gone up by 1. So it used to be medium, and now it's high. So this whole 1.4 is just being able to go and find a certain task in your to-do list and then incrementing the priority. You might have a question, what happens if you increment it when it's already at a high priority? Well, is it in the assumptions? I don't think it is, but it should be in the spec here. Maybe it's not. Okay, but it is in the examples. I know that. So if you go to the examples, you'll see that we have feed dog pets low as the task. It starts off as low. We increment it, goes to medium. We increment it again, goes to high. We increment it again, and then it goes back to low. So essentially, you should be able to cycle the priorities from low, medium, high, low, medium, high, as many times as you want as well. Then in stage 1.4, we also have a bit of error checking. So you'll need to double check. If you actually couldn't find the task, so for example, if we add this task and then search for a completely different task, well, couldn't find it, so what do we do? And essentially, we just print out this error message, could not find task, complete assignment in category COMP1511. So that's the idea there. So read through all parts of the stages, because yeah, even there, we didn't really talk about what happens. Okay, no, that was here. So in the case where the task is at the highest priority, it should be reset back to the lowest. Okay, so sometimes they're a bit hidden. Make sure you double check through everything. And then if you're still confused, ask on the forum. We're happy to help you out. Okay, so stage 1.5, counting tasks. So this one is just a small little extra thing we added to 1.5, to stage 1. And essentially it's just the end command, and it's just meant to count how many tasks you have in your list. So yeah, that's essentially all it is. Cool. So that's all of stage 1. And completing that, I think, gets around 35% of the performance mark, or the entire mark.
It's performance.
Performance. Okay. Yeah, so finishing all of stage 1 gets you a big chunk of the assignment, essentially. And I would say that once you've completed the week 8 labs, you should be ready to essentially go through all of stage 1 and finish all of it. So I recommend doing the labs before you try and complete the entire assignment. But if you're feeling confident with linked lists after watching the lecture, feel free to go through and try this out. But the labs are meant to also help you out if you're struggling with any part of the assignment. Okay, so that's stage 1. We can go to stage 2 now. Essentially, stage 2 is more advanced linked list knowledge. That's the idea behind it. So the diagram you can see here has gotten a bit more complex, and we'll go through what everything means here. But a big part of stage 2 is stage 2.1. So the idea is that we've got our linked list of tasks from stage 1. That's all awesome. But if you have a to-do list, it's kind of a normal thing, right, to complete your tasks, to actually finish them. We don't just want to have a to-do list where it just keeps building up and up and up, even if we finish stuff. So stage 2.1 is about task completion, which is literally saying C, which means I want to complete a task. That's the command. It has the name, this task. It has the category here. And then we say when we started the task and then when we finish the task. So a lot of stuff here, a lot of stuff going on. But once again, we provide you with this nice little helper bit of code to actually pass this entire line. And then you've got all your variables here. So the task, the category, the start, and the finish time. So yeah, make sure you read through all of that as well. But what actually happens when you finish a task? Do we just like leave it in memory, or do we just like ignore it forever? And the answer is no, we do not. So what we want to do with completed tasks is actually store them in our to-do list still. So if we go back to this diagram, what we'll notice is that this task pointer points to our normal task list, right? It's got this struct task that points off the null afterwards. But we also have this completed task pointer that points into a struct completed task that points into another struct completed task. And then all these completed tasks also have the finished tasks themselves. So these are tasks that we actually completed before. So this struct task here, that's essentially what's going on. So this is something that we probably won't cover explicitly in lectures, but once you get a good grasp of how linked lists work and how pointers really work from like structs to other structs, this should be okay. We like to think of something like this as like wrapping this struct completed task over this other struct task. So they're kind of combined together into one thing. But you can give it however you want. This diagram is probably the most useful. So just make sure you understand it once you start, that's all. Okay, so there's a lot of information here about what you should be doing. And it is really important to understand what's going on here because it is probably one of the harder points of the assignment. But once you get it, it should be okay. So essentially, we've got a bit of a diagram example here, which might make the most bit of sense for you guys. But if we added a bunch of tasks here, we'll see that our to-do list should essentially look like this. Then if we ran the command C mark tasks 1511, 600, 720, then we're saying we're going to complete this mark assignments in the category 1511 in this time frame here. And so once that all runs, what's going to happen is that we're actually going to take this struct out of the linked list, and then we're going to wrap it like inside of this completed task and add it to this new linked list. So the idea is we're grabbing out of the original linked list and then pulling it into this new linked list and adding it to it as a result. So this struct completed task will actually get created at the point that we move the other task out. So it's going to be a lot of moving parts, a lot of stuff going on at once, but it can be useful just to think of this as these atomic operations where it's like, you've got this linked list. First thing you do, move out the task that you find. So move it out of the linked list. So the linked list should still be fine. Like afterwards, it'll look like this whole thing here. Then after you do that, create a new completed task, put the other task inside of that, and then add it to the new list. So there's basically 3 steps there. Take it out of the first list, move it into a new node, and then move that into the new list itself. So it can be confusing, but hopefully it should make a bit of sense. Even if we go back to our example here, if I went out and I said complete read assignment 2, 1511, 600, 720. So that's a start and finish time as well. What will happen is that if I press P, we'll see it got deleted from the original list, right? Because there used to be 3 items here. And then if you press capital P, which is stage 2.2, it prints out our completed tasks. So you press enter. We'll see now it gets put here instead. And so we also have this nice little formatting for like it's 10 a.m. to 12 p.m. That's when the task was completed. And we can also do this for other tasks like watch live stream. We'll say it finished, we'll say 7:50 to 8:10 or something like that. If we press, oh yes. So I forgot to include the category here. And as a result, the program's told us I could not properly pass this whole thing. I don't know what's going on. So what you want to do is actually include the category. Like so. Cool. And then if you press P, we see when we have one task in here now. If we press capital P, then we'll see that both of the completed tasks are here. And so the idea is that every time we complete a task, we take it out of the original list and add it to the head of the new list. But obviously it's wrapped up now in a completed task struct as well. So hopefully that was okay. There's an extra part of stage 2.1. If you specify the start time to be -1, then it should essentially just be set to whatever the finish time of the latest thing in the completed task was. That might be a bit confusing. I will show you what that means. So if you say C, buy milk, personal, and then, I don't know, -1 till 900, then hopefully when we press capital P, we will see that the start time for buy milk is just the end time of the latest finished task. So hopefully that should be okay. All right, and then awesome thing, once you've completed all your tasks, you can actually press lowercase p again, and you should see all tasks completed, you smashed it. Awesome. Okay, cool. So that's 2.1 and essentially 2.2. 2.3, expected completion time. I would just briefly go over this one. Essentially, once you've completed a bunch of tasks, you can kind of know the average time it takes to complete a task in a certain category. It's a bit like not completely accurate because it might take a lot longer to do the same task in a different category. The same category. But essentially, this is just to kind of guess, based on your completed tasks, how long your current task list should take. So the idea here is that you look at tasks that have already been completed in the same category, and then you average the amount of time it took for them, and then that will kind of show you how long it should take for the current task. Yeah, so feel free to read through these examples. They should be pretty good for it. But essentially, these are like all the expected times before you finish anything. Default's 100 minutes. Then once you complete one of the tasks, it'll probably update the other tasks as well. And then once you complete another task, the average will change because you've completed more tasks in the same category. And so the expected completion time will now change as well. So yeah, this one's good to go through the reference with just to see what's going on. But I won't go into that into too much detail anymore. Okay, and that's all of stage 2 actually, just those 3 things. Stage 3, I will probably not go into much detail either. But essentially, this is going to be content that you guys learn in the lectures in week 8. And it's just to do with deleting things in linked lists. So right now we can add nodes, we can malloc nodes and then add them to the linked list. But we need to tell our computer sometimes I want to give this memory back. And this whole stage is going to be about that. So I won't go into any detail with it really. But a lot of it's going to be about actually deleting nodes and then freeing them, we say. Yeah, and then the other thing we're doing in stage 3 is finishing the day. So that's actually going through and deleting all the completed tasks. And then in stage 3.3, we can actually allow tasks to be repeated. So a repeated task just means if you finish in one day, so you complete it and then you finish the day, then it should be added back to your original task list. So it's just some daily thing you might do. Eat lunch, for example. That's a task, hopefully. And then that would just be a daily repetition that you do. Cool. And I won't go into stage 4 either, I think. So I will just show it here. Stage 4 is a lot of more advanced stuff. So this is mostly student-led. We won't help you too much with it, but there's 3 components to it. We can't provide too much help, but if you need any clarifications or anything, feel free to ask on the forum, and that'll be okay. Okay, awesome. And Ben, do you want to go over
Yes,
this
I'll go
condenser?
through the boring stuff. Okay, so hello everyone. Just going through some of the less exciting stuff, just in terms of the admin side of things. We can see down the bottom of the spec, there's our submission command and all that usual stuff. And we also have an assessment scheme, which breaks down how you can get the marks for this assessment, basically. So we can see going through, as Rory mentioned earlier, by completing stage 1, you can get to a 35% performance mark. And then we sort of incrementally increase that as we go through the assignment. So stage 2 is 60%, stage 3 is 80%, and so on. So yeah, it sort of reinforces that really stage 4 is if you're wanting to sort of get as close to full marks as possible. We really, again, aren't expecting everyone to complete stage 4, but if you can make as good an attempt as you can at the assignment, that's really all we're looking for. Another thing that's worth mentioning is that we will add a style rubric to this assignment spec over the next couple of days, hopefully. And so that will, weeks, sometime, 24 hours, perfect. Over the next 24 hours, we'll add that style rubric. So it will be down around here somewhere alongside the performance scheme. Figured, never hurts to give us a bit more time. And so that will sort of give you a guideline as to how you can get the most style marks for this assignment. I believe style marks will actually be worth 20% of the overall assignment marks. So I think that number needs to be updated to 20.
Oh, it's 10 and 10.
It's 10
10 and 10.
10 is
Okay, so there's another
is for
10.
Functional decomposition
Of
and
course.
use of control logic.
Yes. So 80% performance marks, and then 10 plus 10% for non-performance related things, which will be marked manually by a tutor. So yeah, again, that'll pop up down here over the next 24 hours. Similar to assignment 1, we aren't really banning any C features, except for, I believe in stage 4, we state that you cannot use any functions that come from the regex.h library. This isn't something we teach in the course, and it actually won't help you complete the assignment, it'll just make your life harder, but we've banned it just in case. But other than that, anything that is in C that is not banned by the style guide, which I believe we link to down here, so just check that out, is good to go. So you can use whatever you like in this assignment. And yeah, I guess the lucky last thing is that the assignment is due on the 18th of November. That is the Friday of week 10 at 8 p.m. So we released the assignment yesterday. It's due end of week 10, so that gives you about 3 weeks to get started on it.
More than get started.
Get started and complete it, hopefully. So yeah, again, as Rory's mentioned, camera's kind of freaked out. There we go, it's back. As Rory's mentioned, the labs and lectures for the rest of the term are really focused on linked lists and helping you wrap your head around them and how to operate them. So they'll be super useful for the assignment. So again, if it all seems a bit terrifying and confusing to start with, don't stress. Tutors are here. Lectures, help sessions are all available. And the forum is always useful as well if you've got any questions.
Lecture program in week 9 will be...
Right, yes. The lecture program in week 9 will be sort of a mini version of the assignment. So, or it was maybe week 8. What week are we in now? Week 7. Week 8, probably.
Yeah.
So, we know what's going on. Week 8 will be a lecture program that's sort of, a smaller version of the assignment with a different theme, but it will really help you get started, especially on stage 1, and maybe a little bit of stage 2. So make sure to check that out if you're not sure about anything. Aside from that, I believe that's everything we really have to chat about for the assignment. So best of luck, have fun. I'm sure you'll have a lovely time with it. Maybe not to start with, but by the end, hopefully you've enjoyed it and, more importantly, got a lot out of it in terms of working with linked lists. If that's all, I think we'll say our farewells. So goodbye from me.
Goodbye.
Bye.
And Sasha's in the background and says goodbye as well. Let us know if you've got any questions. And thank you. Bye-bye.